How's it going, everybody? In this video, we are going to be taking a look at the not-so-stubby area, or the NSSA area. And if you're not familiar with this area, it's a little bit different than what we talked about in our previous video of the stub and the totally stub areas, but they pretty much do the exact same thing, but with a lot of caveats. And what I mean by caveats, there's a lot of little things you have to know when you're dealing with NSSAs and the not so totally stubby areas that you need to know before you start deploying them. Now the main difference between a stub and a not so stubby area is with a stub and a totally stubby area, they block type 5 and I should say out of the gate, type 4 and 5 LSAs out of the stub, and type 3, 4, and 5 LSAs from the not so stubby area. And each one will advertise a default route and to inter-area routes. So the idea with NSSA is you're going to be doing the exact same thing. However, you're going to allow redistribution directly into the not-so-stubby area with the generation of a Type 7 LSA. Now, I've already covered the LSAs already, so you should be familiar, at least from a high-level overview, of what a Type 7 LSA is. It's a Type 5 LSA, so it's an external route being redistributed into OSPF, except for it's being redistributed into a not-so-stubby area. And because it's going into a not-so-stubby area, it has to be advertised into the area through the ASBR via Type 7 LSA. So if you see Type 7 LSA, that is a not-so-stubby external LSA, and it does carry the same characteristics as Type 1 and Type 2, or N1 and N2. So we'll talk about that as we go further along. But I wanted to apologize in advance. This is probably going to be a lengthy video, and I might even have to break it up into two parts. And the reason for it is because when I was studying for my CCIE, which I don't have one yet, but I'm currently working on getting it, when I was going through the meat and potatoes of my CCIE prep, I realized the complexities of how the not-so-stubby areas can be. And I was pretty taken back when I was in my CCNP trying to study for that, going through the route exam. And then once I made the migration to IE to go to the expert level, then I realized how much more I had to learn about not-so-stubby areas and totally not-so-stubby areas. Or I should say not-so-totally stubby areas is the correct way to say it. So, with that being said, I wanted to make sure that I went into enough detail so that I would make sure that you guys understood what was going on behind the scenes, and that there would be a level of understanding that you would be able to take forward if you need to. And the reason for that is because NSSAs are not very widely used. I can name one environment out of the 15 that I've been in the past few years that I've actually seen NSSA areas in, and it was a government agency. So that being said, it's not widely deployed. No customer that I've ever worked with that's either private sector or public sector uses them. They might use a stub area based off of my recommendation for something, but 99% of the networks I've used don't even bother with them, because there are complexities that come with them that if you don't understand them, then you can break your network. So what is a not-so-stubby area? Well, it's defined in an RFC 3101, which extends the functionality of stub areas to allow the origination of an external route into the area. So remember, within a stub area, Type 5 LSAs, so external routes being redistributed into the area, were suppressed from entering the database, and then you could replace them with a default route. Now, this is if you're using the stub command. So if you type in stub on the ABR and the router that's acting as the non-backbone router, those two routers had to run the same stub flags. So again, stub and stub no summary are compatible. NSSA and NSSA no summary are compatible. You cannot run stub and NSSA no summary. They are not compatible stub flags. So just make sure you're aware of the compatibilities with how that works. So it also goes kind of back to when we talked about with network types. Broadcast and non-broadcast multi-hexes are compatible. Point-to-point, point-to-multipoint, and point-to-multipoint non-broadcast are compatible. So if you have the broadcast and non-broadcast generates a Type 2 LSA, which is the DR. Point-to-point, point-to-multipoint, point-to-multipoint non-broadcast do not advertise a Type 2 LSA. Therefore, there is no DR-BDR election. So if you're going to be receiving Type 2 LSAs and you can associate the Type 2 LSA to the network type, that'll save you a whole lot of complexity when trying to design your networks. So if you want to use point-to-point, you're not going to have a DR election. Now, the whole idea of being able to redistribute a route into a not-so-stubby area is to get routes into it. Now, as we go through this section, I want you to be very, very aware that this is going to be one of the more complicated designs that you're going to get into, because you can thoroughly screw something up if you don't know what's going on. So I'm going to break this down into pieces. I'll go and I'll draw it out, and hopefully that'll send everything home for you. So again, NSSA option changes the behavior by allowing redistribution into the area while blocking external routes from entering the area through the ABRs. Now, this is a key piece, blocking external routes from entering the area through ABRs. Now, it's by default, and I'm actually going to jump ahead just a touch, when you have an NSSA area, you do not automatically originate a default route of any type. You don't originate any default routes. With a stub and a stub no summary, you do originate a default route by default. This is why most network administrators that I've worked with like them, because you don't have to worry about trying to figure out who's going to do what for you. Okay, so basically the idea is when you implement an NSSA, it automatically advertises a new LSA type of Type 7 NSSA external LSA. Now, routes that are redistributed directly into the NSSA are generated as a Type 7 LSA. Like the Type 5, there's two subtypes, N1 and N2, where N1, similar to E1, considers the metric that the ASPR reports to the OSPF domain along with the metric needed to reach the ASPR. So again, it's going to redistribute with a metric of 20 by default. So that's going to be the original, what they refer to as the seed metric, when it's redistributed on the box that it's redistributed from. So if you redistribute on router 1, which we are actually, then it's automatically going to be getting a cost of 20. That's going to be its seed metric, and then as it goes to the ABR, to the next hop, whatever that cost is to get to the ABR is going to be added to the original metric that's redistributed with. So when the ABR wants to get to the Type 7 LSA's origination, he's going to have to use the cost to get to the ASPR's advertising to get to the ASPR, plus the actual value that was originated. So that could be a 30, it could be a 21, depends on the type of metric you're working with. It could be some other unique metric depending on how you deployed, if you're getting fancy with your OSPF reference bandwidth command. So, and then with N2, similar to E2, separates the metric into a flat value. So basically, whatever you redistributed as from the ASPR, that metric just carries through. It doesn't increment, which is nice. Most places like that. However, if you're going to be doing that, I've actually come into quite a few situations where by manipulating N1 versus N2, you can affect your path selection because the lower or the better metric wins. So usually N1 will win over N2 depending on the situation and depending on the design. Now I'm not going to go off into the weeds on design, but at the end of the day, the best metric will win. Typically the lowest will win, so N2 usually wins in most cases, but we'll talk about that more in detail later. Now, when the Type 7 LSSA is received by the ABR and is moved into Area 0, the information contained in this LSA is normally translated from a type to a normal Type 5. This is what they like to refer to as the Type 7 to 5 translation. If you have the Type 7 to Type 5 translation enabled, there is this interesting bit called the P bit, or the propagate bit. P is in Paul, Peter, whatever. The P bit is what actually allows the propagation from Type 7 to Type 5 LSA from the NSSA on the ABR into either the backbone area or the non-backbone area. Now, in order to be considered an ABR, you need to have at least one interface inside of Area 0, right? Well, we've done that. So on our set of router 3 and 5 are ABRs. So is router 2 and 4, because we're running virtual links between 2 and 3 and 4 and 5. So that means that router 2 and router 4 are both considered to be ABRs. So they should be able to do the translation by default. Now, If multiple if multiple ABRs exist, only one of them performs a translation through through an election process, which is we'll talk about later on. The reason for this is if you learn a route in for one ABR and you take that route and you move to somebody else, you could be double advertising, and that could break your network. You can get a loop. So now, as we go through here, let me talk a little bit more about this in detail because it's important to understand all the details to this. So, a pitfall. The other key between stub and NSSA is how the default route works. Okay, the stub area removes external LSA and replaces them with the default route. Okay, that's why people like them, because they're simple to use. You type in area whatever stub on two different routers and you're done. Type 5 LSAs are poof, they're gone. Default route is advertised as an inter-area route. And if you want to know how to get there, you take a look at your OSPF database. You type show IP OSPF database for the summary LSA, and guess what? You pull that up, you're going to get a default route. It's going to be all zeros pointing to the ABR's advertising router ID, which is going to be the router ID. Pretty straightforward in that case. Okay, if you were having a hard time following along with my recursion videos, if you've been following along, you will see that as I'm going through, I'm showing you how to recurse through the LSA types, because that is the most complicated part. If you don't get that, you're going to have a hard time understanding where things are going wrong. The totally sub area extends this by replacing type 5, 3, and 4 LSAs by default with the default route. Okay, so you type in stub no summary on the ABR, then the router that's on the non-backbone or an internal router is going to get just a default route for inter-area routes, and any intra-area routes are just going to be just that, because you're not going to use an ABR to reach an internal route. So that's why they're called intra-area routes. And then we'll get into more of the hierarchy as to why you're going to choose intra-area versus inter-area versus E1 over N1 over E2 over N2, and go through all that stuff. So we'll get to that. That's going to be coming up. I wanted to get through the stub types first. So now, however, within NSSA, a default route is not automatically originated by the ABR. What this means is devices within the NSSA will have reachability to their own area and to other areas, but not to destinations outside of the OSPF domain. So now I'm going to go a little off kilter here, but this is I think is going to help dial this in a little bit for you. So if you skip from type 3 to type 5 LSA, this means you are this is an intra-area external route. This means that you have solved the shortest path tree to the ASBR, which can be the ABR at the same time. So if you're skipping from type 3 to type 5, that means that you're in the area that the type 5 was originally advertised into, which means you don't have to leave your area to reach the external route. Okay, if the ASBR is in our area and the shortest path tree is correct, the routing bit is set. So that's going to be the key feature. I keep pointing it out to you guys. The routing bit must be set in order for you to verify that recursion is working. Then we will use the cost of the ASBR as advertising to the external route. You would do this by looking at the OSPF database external and the route that is being advertised. Okay, so pretty straightforward there. Now, if the ASBR is not in our area, we would have to recurse to a type 4 LSA lookup, which would recurse to the type 3 LSA, which would recurse to the type 1 LSA. Confused yet? Okay. So the idea is, if you're going to go to if you have to get out of your area, you're going to recurse to the type 4 LSA to see how do you get to that. So then what you would do is, once you get to the ASBR, you would hit to figure out what the next hop is, which would be the type 3 LSA. There's a question posted in between. Actually, I had to pause the video for a moment. There was a question asked when I paused. Why do you have to recurse to type 4? Well, because you're advertising a route from from a not so stubby area. Any router that is sitting in any router that you are originating a redistribution route into, the router automatically becomes an ASBR if it's going to be attached to the area in which the external route is sitting in. I'm sorry, no, that's not exactly 100% true. If the you can't have an ABR sitting on the edge of a not so stubby area, because it's got to be able to bring in external routes. So by the moment you redistribute something into an area, then all of the routers in that area technically become ASBRs. And the reason for that is because when the routes come in, they are learning the type 4 LSA. So we'll take a look at this in more detail in here in a few minutes when we actually get into the deployment. But the entire point of the ASBR is your. So let's get a little more zeroed in on it. Look at just one router, and this router is redistributing a route into OSPF. Because it's bringing in an external route in, it's automatically going to have a connection to an outside entity. So actually, that last comment I made about all routers being ASBRs, I'm technically not 100% sure if that's 100% accurate. So just forget that I even mentioned that piece. So the router that's sitting anywhere in an area that receives a route and it's not an OSPF route, it's external, that's an ASBR because it's going to have access to an outside entity besides the OSPF domain. So what that means is, in order to get to him, you would have to recurse to a type 4 LSA lookup wherever you're at. And this is if the ASBR is not in your area. So you have to look up the type 4 LSA, and that type 4 LSA, once you know what the next hop is going to be, whoever advertised it to you. And that's going to be pointing towards another area. Then you're going to be also doing a type 3 LSA lookup to figure out which ABR you need to talk to get to that next area, as well as then doing a type 1 LSA to a route to where you need to go. So that's the general idea behind it. Now, LSA 1 would follow the shortest path tree to the LSA type 3. The ABR then would follow type 3 LSA to follow the shortest path tree to the LSA 4, which would lead to the external route. So the idea behind it is when you're trying to go anywhere inside of your entire OSPF domain, you're going to be, if you're in your area, if the route is originated in the area you reside in, the type 1 LSA lookup, because it's an intra-area route, because the router LSA is generated by. If you're inside the OSPF domain but not in your area, you're going to recurse to a type 3 LSA, which is the ABR, and then you're going to recurse to a type 1 inside of that area. Now, if you're going multiple areas away, then it would be type 3 to type 3 to type 3 to type 1, depending on how it's getting advertised. If you are trying to leave your OSPF domain and go to an external entity, which either another routing domain, the internet, or wherever it might be going, it's going to be external to OSPF. You're going to be going from a type 1 LSA up. So you're going to be recursing to a type 3 LSA, which if it's inside your area, you're going to be recursing to a type 5 LSA out of the gate to reach the external route. If you are trying to reach an area or route that's not in your area, you're going to be recursing to a type 3 LSA to get out of your area, assuming that router isn't an ASBR already. And then you're going to recurse to a type 4 LSA, which is going to be the Autonomous System Boundary Router. And then once you're at the ASBR, you're going to look in the routing database and you're going to see, I need to forward to the type 5 external, and then that's how you recurse to type 5. So in your inside OSPF, you're going to go from down, or from the highest LSA number down to a type 1. If you're going from OSPF outbound to another area or to another routing domain, it's going to be going from the bottom up. So type 1 to type 3 to type 4 to type 5 to type 7, however it might go. So the not-so-stubby area will advertise a type 7 LSA. If the not-so-stubby area external LSA has the forward address as a non-zero value, this address, this is the address that the rest of the OSPF domain will solve to the shortest path tree to the type 7 LSA. Confusing myself with my notes. Give me a second here to filter to fix these guys. Okay, so the forward address is used only in external routes. So if the not so stubby area external LSA has the forward address as a non-zero value, okay, that means it's going to have the address of the router. Because a non-zero value means the next hop is OSPF. If it's a zero value, that means the next hop is going to be a non-OSPF next hop. So this is the address that the rest of the OSPF domain will solve the shortest path tree to type 7 LSA, and this is area local scope. So just to the ABRs in the area, when it hits an ABR, a type 7 to 5 translation is possible. So the idea behind that is if you're trying to route to a area that is you're trying to get out of your area and go to the type 7, you need to translate. The type 7 only comes in. The forward address will come on a type 5 and type 7 LSAs. If normally within type 5 LSAs, you're going to get an all zeros value. If you get an all zeros value, you need to and actually it says we're right here. The next one down. For type 7 to 5 translation means the ABR is allowed to advertise the route to the other area. If the forward address is the advertising router, the same address the ASBR is telling the area to solve the shortest path through to the ASBR. Query LSA1. This is an intra-area external lookup since the forward address has a non-zero value, which means that you're going to be trying to translate or trying to solve the shortest path tree to a value that you have actually access to via OSPF. So, non-zero value means that it's an OSPF next hop. So, and that doesn't necessarily mean that it's going to be the advertiser may not be actually the route you take, which I don't. It gets really complicated. That's why I'm saying this is much more difficult to comprehend sometimes as we're going through here. So the forward address is the address to use to determine how to get to the external route, and this is typically going to be used with type 7 LSAs because the fact that the ASBR is going to be advertising a route to a router that's inside the not-so-stubby area that's actually going to have the route to reach the external domain, which could be just a loopback that you've redistributed in. So that's the idea behind how that works. So now what I'm going to do is I'm going to show you how to configure this, and it's literally just 2 commands, and I'll show you exactly how this breaks down, and we'll go from there. So we pull up our stuff here. So right now on router 1, I'm redistributing a loopback into router 1, and that's going to be advertising a type 5 LSA to 4 and to 2. So now what I'm going to do is I'm going to go in on 1, 2, and 4 and put this guy into a not-so-stubby area. So I'm going to pull this guy up. I'm going to bring this guy down a little bit. And on router 1, if I jump out here and type in, and don't pay attention to the checksum. And it seems like that the checksum only happens on that one router. Let's see if it's on 2 it's happening, 3 it's happening, 4 and 5. Yeah, I don't know why that's 17. Why did it go down? Oh, it just came up. Interesting. Anywho, so on 1, we do a show run pipe section OSPF. Let me show you what I've got going on here. Alright, so on OSPF, on area 123, where you're doing a redistribute connected subnets route map OSPF. So I do a show route dash map. You'll see that I'm advertising 3 loopbacks into OSPF. Do a show IP interface brief. You'll see that loopback 1000, 1001, and 1002. So these 100 routes in here, these guys are being redistributed in. Now we go to router 2. And I do a show IP route. I'm getting 3 external routes in here, right? I'm getting the 3 routes here. Same thing with router 4. Show IP route. I get the 3 external routes. 100, 101, 102. Now what I'm going to do, and router 3 is receiving them as well. Show IP route. We're getting the 3 external routes. So as you can see, all the way through our entire domain, show IP route, we're getting the 3 external routes. Okay. What I'm going to do is on router 1, I'm going to configure area 123 as a not-so-stubby area. So router OSPF 123, area 123, and the question mark, and if you see NSSA sitting there, so specify a not-so-stubby area, NSSA, question mark. And you have a couple of options here. And we'll take a look at exactly how this works as we go through here, but You have no summary. You have the translate, which is translate LSA. I'll talk about that here momentarily as we go through. This is actually typically done on the ASBR, like 4 and 2, to determine who's going to originate the LSAs. I'm going to hit enter. I'm going to go over to router 2 and 4 and do this as well. Go to global config, router OSPF 123, area 123, NSSA. That should resync. Actually, hold on. Do show IP protocol summary. OSPF. No, OSPF 2, sorry. Actually, exit out of here and router OSPF 2, area 123 NSSA. There we go. So router 1's back out because he's got the right flag set. So let's go to router 4 and config T. Do show IP protocols, or it should be OSPF protocol summary. This should be OSPF 4. Router OSPF 4, area 123 NSSA. Okay, that should reappear. Now, if we go to router 1 and do a do show IP route, notice how everything shows up as these are all connected routes, right? We have some inter-area routes. Everything looks good there. Now, if we go to router 2 and we type in do show IP route, we should see an N2 route. The same place, right? Now, N2, we're getting that in, and everything looks good. Let's go to router 4. Do show IP route, and I see the N2 routes here as well. Now, here's the real test. We go to router 3 and see if we're loading them in. So, show IP route, and we are not. They're coming in as E2 routes, and they're coming in router 2. Let's go to router 4. Well, actually, we are learning them because they're coming in as E2 routes. But is that right? Should they be coming in as E2 routes, or should they be coming in as N2 routes? Well, if they're coming in as E2 routes, what does that tell you on router 2? What's happening on router 2? The type 7 to type 5 translation is happening, because the fact that 7 to 5 is being translated so that it's going from a type 7 N2 route to a type 5 E2 route. Router 3 is receiving it. Let's go to router 5 and do a show IP route. And we have E2 routes coming from 4. So we try to do a trace route to 100.100.100.100. We go via router 4, right? Everything looks good that way. So we're good in that direction. So we take router 3 that way. Router 4. We take router 4, let's go to router 3, and we do a trace route to 100.100.100.100, which should go router 2. And we do. We get to where we need to go. Now, let's take a look at this. If on router 1, the work we're going to be spending now is going to be in router 2 and 4, because we want to make sure that we advertise this correctly. This NSSA area here. Now, remember what I said about that P bit. The P bit is what determines what routes what not so stubby areas, or not so stubby area routes get translated from type 7 to type 5. So you can type in this translate and type 7 to always, which this command right here, what this would do is this would make sure that router 2 always translates type 7 to type 5 LSA. So now you have this always command, and you have this suppress forwarding address. Let me actually dig into this a bit and so do a show IP OSPF database. So let me come down to the bottom here, and we have a bunch of routes in here. So I'm going to scoot this guy up here just a little bit so you guys can see it. So we have these summary ASBRs, right? Then we have these type 5 external routes, and notice how they're type 5 external. So what we need to do is we need to take a look at these and say, okay, out of area 123, that's area 0, we need to take a look at this 2, 3, 4, 5, 123 should be up here. Type 7, this is what I'm looking for right here. So we have the type 7 LSA, right, because we have the type 7 AS external. We have it coming from this guy. So let's take a look at this guy and do a do the NSSA external for this guy. And if we look here, it says that we have in area 123, we have the routing bit is set, type 7 to type 5 translation to set up. We have the demand circuit because it's coming across the wire from this guy, or I'm sorry, just directly connected. Its upward bit means that it's receiving the route in, and it's not going to advertise it back out because it potentially could. Or no, sorry, I'm incorrect on that. That would be the down bit. We have the external LSA, or the external network number. We have the advertising router, but notice what we have here. The forward address. It's a non-zero value. So what is 10.11.10? Well, 10.11.10 would be what address? Here. Do show IP interface brief. 10.11.10 is just a loopback that we have set up here. And 10.11.10 is the do show IP OSPF neighbors. That happens to be, or OSPF brief, or OSPF. That happens to be, and the router ID is not that. The router ID is this guy. So what is? Or no, wait, hold on. What is 10.11.10? Type of show IP route 10.11.10. It's okay. It's an intra-area route being advertised by this guy. Don't know why it's advertising that route, because that route technically doesn't mean anything. I don't know why I chose that one. But the forward address is a non-zero value, which means we have to have a route to 10.11.10. So that's why this is showing up the way that it is. Click back inside this, and so we have a forward address of 10.11.10. We have to have a route to this guy. Now, if this is a non-zero value, then we're going to have to traverse to the 10.255.11. The reason for that is because if this is a non-zero value, OSPF thinks it's a non-OSPF route. Then we have to look at the advertising router. If the area here, if this guy is a non-zero zero value, so a forward address of all zeros, then we're going to recurse to 10.255.11. So that's the idea on the ASBR, which is what these guys are, because of the fact that they have a route to where they need to go. So now we can do the same thing on 4. Let's jump out of here and type in show IP OSPF show IP OSPF database for the NSSA external, and we're going to have a few of them in here. Notice how the same address keeps popping up for the 101, 102, or 100, 101, 102. Okay, so that means 4 is advertising it. Now, if we look at router 1, though, we jump out here to a show IP route. What don't we see in here? We don't see a default route. And by default, you're not going to get one. So if we wanted to leave this network, so right now we're advertising a route outbound for OSPF, and we're getting that as router 3 is learning it in as an external. So if I wanted to go to router 3 and do a trace route, which we already did, then I'm going to be able to get out to it. Now, once we get a little farther along here, what we'll have to make sure is to advertise a route into OSPF. Now, let me show you how this is done. On router 2, I want to make sure that when we redistribute a route, or if we advertise a default route in, that we're taking it and setting it up so that we are allowing inter-area routes. There's 2 ways of doing this, and off the top of my head, I can't remember which way is which. So I'm going to do it both ways. I'm going to type in router OSPF 2, type in area 123 NSSA question mark. Now there's 2 ways you can do this. You can either do a default or information originate, which originated a type 7 default into an NSSA area, or you can do a not so stubby area or no summary. If you do this one right here, you're going to be suppressing all the type 3, 4, and 5 LSAs going into the NSSA so that what router 1 will receive. If you do default information originate, you're going to keep the type 3 LSAs in the routing table. In addition to that, be advertising a default route. So on router 2, I'm going to make sure that we can still reach router 1 via what do you call it? A default information originate, and then you can still come in here and you can do a no summary, and you can get into some really weird setups. So I'm not going to go in here. And the other thing too is you can actually set up this to be NSSA only. If you were to do this, the NSSA only is going to turn off the translation of type 7 to type 5, which means that any routes you advertise from router 1 into the not so stubby area, if you use the NSSA only command at the end of the default information originate, you're going to turn that off, and then what's going to happen is that router 2 will no longer be able to translate that. So router 3 won't be able to use router 2 to get to router 1. He'll have to go router 5 to 4 to 1. So I'm just going to hit the enter key here, and that's going to advertise the default route. So router 1, we do hit the up arrow, we have a default route pointing out. So now it's pointing out to this guy. And notice that we also have our inter-area routes. Now, we have the default route pointing to router 2. Now what I want to do is I want to make sure that router 2 is a configuration setup where he can get out regardless of what's going on here, but I want to make sure that router 4 shuts down everything so that that there is no inter-area routes being learned from router 4. So any inter-area routes are going to be just the default of coming from router 4. And the way we would do that is go to global config, type in router OSPF 4, and type in area 123 NSSA and type in no summary. No summary is going to remove that capability, and what is going to end up happening at that point is you're going to be suppressing type 3, 4, and 5 LSAs from being advertised to router 4 and originate just the default route. So all these additional routes you see here that are being advertised from router 4, these inter-area routes, all these are going to get suppressed when I hit the enter key here. So that's going to happen. We're going to hit the up arrow here. Oh, I did it again. We're going to go to router 1 and hit the up arrow, and now we're going to have, notice how that the only one we can get out on here, the only router we can leave the NSSA area on for anything is router 2. Okay, and that's because of the fact that the default route overrides the not so stubby area. Or I'm sorry, the stub, because of the fact that you have a route already being originated. So now if I take this off on this guy and hit the up arrow and type in no, what's actually going to end up happening here is the do show run pipe section OSPF is it will just remove the default information originate command. That the area 123 NSSA should still be there, which it is. On router, it's still there right here. And then we're going to go to router 1 and hit the up arrow. So now, what do we get a route from? Notice how we have just the default route coming from router 4 now. But we still can get inter-area routes out to router 2. So if I want to do a trace route to 172.16.45.5, I'm going to go use router 2 to get there. And why is that? Because I have a longer match via 172.16 right here. I have a /27 route. If I do a trace route to 8.8.8.8, which I don't have a longer match for, I'm going to use router 4 to get out. Notice, see how that works? So depending on how you advertise the route will determine how the traffic is going to get forwarded out of the area. So because of the fact that I have a longer match with a /27 to 172.16.45, I'm going to use router 2 to get there. If I don't have a longer match in my local routing table via type 1 or type 3 LSA, I'm going to default to the default route that's been advertised in the NSSA no summary command on R4. So that's why I went to router 4. Router 4 doesn't know how to get there, so it gets dropped. So that's the general idea of how that would work. So if there's not a more specific route, you go router 2. Less specific route, you go router 4. And there's different ways you can handle that, like I just showed you. So that's just one variation of how you could do that. Now, I would recommend playing with this if you're going to get in, if you want to really get into it and see exactly how this stuff actually works, because it can get very, very complicated very, very quickly if you don't understand what's going on here. Now, one of the things that I want to do now is on R1 or R2 is I'm going to make this a not so stubby area, but at the same time I'm gonna actually I have that command. So then let's see here. Pull this guy out here. Question mark. And I'm going to not so stubby area. Actually, no, on router 4 I'll do it. I'll do it on router 4. I gotta get a new mouse. I keep kicking these guys out here, and I don't mean to. No summary. Now, question mark. I can't do it the way that I want it to. Translate. Type 7. Always. Yeah, they're not going to let me do it here. There's a question. What are these other ones? So default information originate. Actually, let me just do the question mark here. So the default information originate is going to allow you to advertise a default route in addition to your Type 3 LSAs. So you're going to be able to do that. The no external capability is going to do not send domain-specific capabilities into NSSA. I believe this is type. I don't exactly know what that means off the top of my head. No redistribution means you're not going to allow redistribution into this NSSA area. So router 4 will not allow a type 7 to 5 or type 5 to 7. So you won't be able to advertise a default route in through router 4. And then no summary means you're not going to advertise a summary route in addition to the type 5 and 4 LSAs. So this means that you're going to just advertise a default route. That's why I was able to take longer match routes from router 2 to 3 to 5 that way, and I was able to go, because we look at router 1 again, for that route I went router 2 to 4 to 5. Now if I was to do a trace route, do a show IP route again, we're going router 4 now because I pulled that default information originate, or that command off. So now if I do a trace route to this guy, I should go router 2 to 4 to 5, which I do. And then if I do the default route, I should go router 4, which I do. Because remember, the longer match routes are still being advertised via router 2. And I have a default route going router 4. So the minute I pull this command off of here, so if I type in no here, and I type in, now it's going to break it, type in area 123 NSSA question mark, and I type in no summary question mark, and excuse me, no summary, that'd be the same thing as me advertising a default route without advertising longer matches. So that's one way to handle it. So it just depends on how you want to do it, and go from there on it. But now, with that being said, if I type in no redistribution, so let's say for instance I type in no redistribution here, no dash redistribution. What this is going to do is if I type I'm not going to allow external routes to be redistributed into this area. I don't have anything to advertise right now, but that's how it would work. So that's pretty straightforward with the NSSA. Now, if you want to type in here, let's see, no summary. Why does it seem like the command is now gone? Area 123 NSSA translate type 7 always, but I want to, okay, no, it's not, suppress a forwarding address, yeah, let's see here, no summary, no dash redistribution, translate, suppress FA, always, Yeah, you can keep tacking things. I'm actually looking for the NSSA only, and I don't see that command coming in anymore. And that's frustrating because I wanted to show you how this would work to where it would only allow it to come in. Maybe that's because of the fact that the way that I've got it set up. So do show run pipe section OSPF. Let me do that first. Let me see how I have it advertised. Let me pull them out real quick. Yeah, I don't have anything special going on there. And let's go to, or wait, hold on. Was that area? Oh, yeah. And then type 4, do show run pipe section OSPF. Okay, so area 123, NSSA, no dash summary. Let me actually scroll up here just a few here, because there's some commands in here that aren't available anymore. Oh, that's not it. I think it's over on 2 that I saw it. Yeah, right here. Oh, that's what it was. That's okay. That's my problem. So we're gonna do this. So area 123 NSSA default information originate, and then okay, there we are. So now what I can do is I can advertise a seed metric or metric type. So I can set the metric type on here to be type 1. So if I type in metric type 1 dash type, and I can specify type 1, and then I can say, like I don't want these routes to leave, so I can say NSSA only, and I can hit enter. And then what's going to end up happening is when I go to router 3 and do a show IP route, I will be learning the as soon as it updates, which might take it a second. He should be learning them, so let's do a clear IP route star. So he should be learning those routes from router. Let's see what 5 is learning. Okay, so as you can see here, we're getting dual routes here, but router 5 is not learning them from 4 for whatever reason. Let's see what's up with that. Let's do a clear IP OSPF process. Yes. Yeah, there's a comment. This stuff can get really complicated really quick. It can, and that's why it's Alright, so there we go. So now, okay, that I think we should no longer learn. Okay, so the virtual link is up. So we should not be okay, we are learning those routes in. So the idea now, and everything's working as far as I'm concerned. I mean, I was just showing you some of the different capabilities that are available. But the idea now is if we were to do go to 5 and do a trace route to 100.100.100.100, we're going to load balance it to where we need to go. I did the same thing from router 3 because of the way that I'm forwarding it. Router 2 is doing the NSSA only. So I do a trace route to 100.100.100.100. It's being a little weird, and I don't know why. Because it should not be advertising. So if we go to router 2 and we do jump out of here and do a show IP OSPF database for the NSSA external, now I have no type 7 to type 7 to can't talk. Type 7 to type 5 translation. But it's only on so I have nothing on this one for the default route, right? So we're doing that just for the default route. That's what it's being affected for. For the 10.100, it is being allowed, and the forward address is 10.1.10. Same thing on this guy. So the default route is got no type 7 to type 5 translation. So that was my mistake. So if I wanted to filter these routes out on router 2, what I'd have to do is I'd have to go to global config and type in router OSPF2 area 123. Actually, I should say area 2345 because it's the area you're going into. And I haven't shown you guys summarization yet, but if I wanted to, I could type in range and type in I want to type in a default, or no, area range 100.100.100.0/24 and question mark, and then not advertise. What would end up happening is I would advertise and I wouldn't allow this traffic to go across. And advertise means it's going to allow it to go across by default. Not advertise means it's not going to let it go across. So not advertise, and you can hit enter. So now what I should be doing is I should go to router 3 and hit the up arrow and do a show IP route. And as soon as it triggers, I might not be doing that wrong. Or I'm sorry, I might not be doing that right. Clear IP OSPF process. Yes. It does take some time for the LSAs to generate. Now we have to wait for this virtual link to come back up. And then as soon as they come up, okay, that didn't matter. Alright, so for the routes we're trying to send routes into, what we actually can do is we can because 3 is learning them as type E2. When we get into filtering, I'll cover this a little bit more in detail, but the idea now is my intention was to make sure that those routes didn't get advertised. And actually, I'm sorry, I'm kind of doing this a little off, but as you can see here, I'm for the default route, I'm not allowing type 7 to type 5 translation to go across, which is basically telling me that that the P bit has been turned off, but only for the default route. The P bit is still enabled for, so if I was to go to router 3, but I go to router 5, okay, still he's not, so that's working. So let me see what my config is on router 4, and do show run pipe section OSPF. Then I can just make that whatever. So he's literally just doing the oh, that's why. So area 123 NSSA no dash summary. Now when 5 learns these in, when 1 learns these in, he's going to receive a default route from 2 and nothing else. Notice how it's an N1 route, that's what it's being advertised as. And did it again. So 4, no summary, and no redistribution is into the NSSA area. So translate type 7 to, and you can do a suppress FA. Yeah, see, it's I think we're good at this point, because I feel like I'm going to be getting into the weeds at this point, but at least you can see exactly how traffic can forward where it needs to go. And just remember that the default information originate with the NSSA command is going to allow you to advertise a default route plus the inter-area routes. No summary attached to NSSA is going to suppress them and just advertise a default. So depending on how you want your traffic to forward will determine how you want which selection method you use. And then if you choose to disable, if you use the default information originate, and you happen to choose the NSSA only, then that's going to turn the P bit off, but it's not going to allow a default route to come across. So if I was to do this and go to router 1 and hit the up arrow, it's not going to advertise it because of the fact that I have it set up already. But if we go to router 4, we jump out of here and we type in show IP OSPF database for the NSSA external, hit enter. There's no type 5 LSA translation on the default route, but I am translating the other routes. So, and these guys are coming in as type 7 routes. If we go to router 3, actually, let me do this as well. Do a database for the summary. Let's see here, summary. Yeah, summary for. Got a lot of routes in here. I was just curious to see if he was receiving anything in. No, he's not. So if I would have to go to external, there they are. So now I'd have to set these guys up. So 716, do a show IP route. We should be receiving just a default route on those guys. So trace route to 100.1. 100.100.100.100. We go router 4 to get there, because that's just a logical choice. So, but I wanted you guys to see exactly how those broke down, because it can be very complicated if you don't get what's going on. But at the end of the day, it's not super complicated to understand how this stuff works. It's just make sure that you understand, what's where and why. And that should be all you really need to worry about, and go from there. So, pretty straightforward for the most part, but just make sure that you understand the complexities to it. And I think that's as far as I need to take it here. We're going to get into summarization, and we're going to get into filtering and stuff like that, and path selection. And we've already done some path selection, and the easiest way to do that is to manipulate the cost. We're also going to do some other filtering, like type 3 LSA filters and stuff like that can be done, and go from there. So not a ton left to do, but it's important to understand how this stuff works. So I hope this has been informative for you, and I'd like to thank you for viewing.